Okay, let's dive in. We're unpacking something really fundamental today if you're looking to really get good at construction waterproofing, specifically external above ground applications. And our guide, well, we're pulling key insights straight from the Australian standard, AS 4654.2 2012. That's pretty much the rule book. Now, our mission here is really for you if you're currently learning waterproofing, maybe, doing a Cert 3 or similar. We want to sift through all the technical stuff and just pull out the absolute must-knows, the core principles you need to build that solid foundation. So where do we start? What are those essential concepts according to the standard?
Well, I think the first really critical shift in thinking is that the standard, AS 4650.2, doesn't just talk about slapping on some goo or rolling out a sheet. It defines external waterproofing as a complete membrane system.
A system. Okay, so more than just the membrane itself.
Exactly. It includes everything, your primers, any fasteners, the outlets for drainage, flashings. All these bits have to work together. It's designed as a whole package to create that continuous barrier. It's definitely a multi-step thing, and skipping a beat can really compromise the whole job.
That system approach makes a lot of sense, and I see the standard really hammers home the importance of the surface you're applying it to. The substrate, is that the first big hurdle?
Oh, absolutely. It's foundational, literally. Your substrate has to be, first, suitable and compatible with whatever membrane you've chosen.
Yeah.
But beyond that, the preparation has to be, well, meticulous isn't too strong a word.
Meticulous how?
We're talking smooth, no bumps, no holes, no sharp bits that could, puncture or wear thin the membrane over time. And it needs to be spotlessly clean, properly dry, no dust, and within the right moisture content limits specified. Get the substrate wrong, and honestly, nothing else you do on top matters as much.
Wow, okay. So clean is an understatement. It's perfectly prepared. What about getting water off the surface? Falls.
Yes. Falls are absolutely non-negotiable for external areas. The substrate itself, or sometimes a screed laid over it, must be graded. It needs sufficient fall, so gravity does the work, directing water towards the drains. You simply can't have water pooling on the membrane. That's asking for trouble. No ponding, that's the goal.
Got it. Perfect base, definite drainage. Okay, substrate's prepped. Before the main membrane goes on, are there tricky spots needing special treatment?
Yes, absolutely. This is what we call detailing. It's all about protecting the vulnerable areas before the main field application. Think about corners, especially internal corners where walls meet floors or wall-to-wall junctions. The standard demands fillets there.
Fillet?
Yeah, basically smoothing out that sharp 90-degree angle. For liquid membranes, it's typically a 15 mil by 15 mil triangular fillet. For sheet membranes, because they're less flexible, it's bigger, usually 40 by 40 mil.
Okay, why the fillet and why the size difference?
Good question. Sharp internal corners are stress points. The membrane gets stretched thin trying to conform. The fillet creates a gentle curve, letting the membrane maintain its thickness and reducing that stress concentration. It's a really common failure point if you miss it. The bigger size for sheets just accommodates the material's nature, its stiffness.
Makes sense. Avoid stretching it thin.
Exactly. And it's not just corners. Any penetrations, pipes coming through, posts for balustrades, drains themselves, even joints in the substrate, they all need reinforcement. It usually means extra layers of membrane, maybe some reinforcing fabric embedded, and definitely secure sealing around penetrations with compatible sealants or preformed collars. These spots move or see water pressure, so they need backup.
Right, reinforce the weak links. Then comes the main barrier.
Then comes the main barrier, applying the membrane itself. With liquids, which are very common, you're typically putting it down in multiple layers or coats. And a key thing here, something you absolutely have to get right, is the total dry film thickness, DFT.
Dry film thickness, DFT. So that's the thickness once it's all dried and cured.
Precisely. And it's critical because the thickness directly relates to how well it resists water, hydrostatic pressure, and also how it performs in testing. The standard implies, based on testing needs, that for many liquid systems, you need at least 1.2 millimeters DFT. That often means 2 or more coats.
Okay, 1.2 mil minimum.
Yeah, and you can't rush it.
Yeah.
Allowing the proper curing time between coats, whatever the manufacturer says, is vital. It's a chemical process.
Right, DFT and cure times. Tangible checks. Now, what about the edges, where the membrane stops? Against walls, doors, drains, seems like another potential problem area.
Huge potential problem area. Terminations are incredibly important. How you finish that membrane system at edges, where it turns up a wall that's called an upstand, or how it integrates into a drain or meets a door cell, it's all critical.
So how should it finish?
Well, for upstands, the membrane needs to extend upwards to a specific minimum height above the finished floor level, not the substrate level. And it has to be properly secured at the top. often tucked into a reglet or covered with a flashing or held with a pressure seal. This stops water getting behind the membrane. Same goes for drains and overflows. You need a positive, watertight seal between the membrane and the drain body. And around doors and windows, you often need integrated subcell flashings. Get the termination wrong, and the whole system can fail.
Right, so a perfect field application doesn't help if the edges leak. Okay, membrane down, cured, termination sorted. What's next? Just walk away.
Definitely not. Protection. The standard is very clear on this. Once your beautiful waterproof system is down and cured, it must be protected from damage. Think about other trades coming in: tilers, builders, drop tools, wheelbarrows, site debris. It can all puncture or damage the membrane.
Yeah. Makes sense.
So you usually cover it with protection boards, maybe a drainage cell, sometimes a whole screed layer or specific protective fabrics. You've got to guard that investment.
Protect the barrier. Logical. And the final step. How do you actually know it worked?
Inspection and testing. It's non-negotiable according to the standard. There needs to be thorough inspection throughout, but the key acceptance test is usually a controlled water test.
The flood test.
Commonly called a flood test, yeah. You block the drains temporarily, fill the whole area with water to a certain depth, usually covering all the floor wall joints, and you leave it.
For how long?
For a minimum of 24 hours. Then you check thoroughly underneath and around for any signs of leaks, any dampness at all.
24 hours.
Yeah.
Wow, that would definitely show up any issues.
It's designed to. No hiding from that. And one last point. The system you choose in the first place has to be suitable for where it's going. You need to consider UV exposure if it's not covered, the range of temperatures it'll face, any chemicals it might encounter, and really importantly, expected startable movement. The membrane system has to cope with all that without failing. So pulling it all together, especially for someone learning, you'd see it's not just about the product. It's this whole detailed process, a system. Following these steps from the standard, the substrate prep, the detailing, the DFT, terminations, protection, testing, getting these fundamentals right is absolutely essential for a successful, long-lasting job.
Absolutely. It paints a clear picture. These are the real building blocks for developing your skills out on site, understanding the why behind each step, not just the how. So this deep dive really highlights just how many interconnected pieces have to come together perfectly to create that effective barrier, which does make me wonder, with so much detail needed up front to get it right according to the standard, how does ongoing maintenance fit into making sure that barrier actually keeps performing, year after year out there in the real world?